a graph that is below the x-axis, a function that is negative, it is going to return a negative net change. So let's read this next paragraph to study that. If we want to calculate the actual distance, though, traveled by a particle, we have to consider intervals in which the velocity moves, or velocity is greater than zero, meaning the particle is moving to the right, and intervals for which it's less than zero. That is below the x-axis. In both cases, the distance is computed by integrating the absolute value of velocity. Okay, so what everybody has to understand is this. When you integrate velocity, just velocity, it does not give you total distance. It gives you a net change in position. If you actually want to find the total distance that a particle or object moves, you have to integrate the absolute value of velocity. Because what that does is that guarantees that your velocity then will be positive, or that your net change, the integral will be positive, and then that is actually going to give you positive values. Because if you're trying to figure out total distance, you don't want negative values because that's going to subtract from your total distance. So we got two different concepts here that you're going to be tested over. Displacement, which is strictly how far an object has moved from its original position. It's called displacement, or net change in position. And then we have another concept here that's called total distance. That is actually okay. And then to figure out the total distance, you have to integrate the absolute value of velocity. It's very important. In fact, when you're doing your test, AP test, one of the first things they're going to look for if they give you a total distance problem is this integral to the right here with those absolute value bars. That's going to indicate immediately to the grader of your paper that, hey, this person knows what they're doing. They're about to integrate the absolute value of velocity to find distance. Now, we hope we get asked a displacement question because the displacement question is a lot easier. It's not easy, it's just quicker. Okay, let's look at an example. A particle moves along a line with a velocity of t squared minus t minus 6 measured meters per second. Find the displacement of this particle during the time period between 1 and 4, and find the distance traveled during the time period. Okay, I want you guys to look underneath the camera, and I want to show you something real quick. Okay, now we hope we get asked displacement. Okay, I want to look at the graph of t squared minus t minus 6. Just real quick, let's look at the graph of it to kind of get an idea of what it looks like. Now keep in mind, I'm just going to sketch this real quick. I sketched it earlier, so. Okay, now look at this t squared minus t minus 6. Now remember, this is a velocity equation. This is the equation for velocity. When this equation is above the x-axis, okay, that's over here and over here. This is time in the negative realm, so it doesn't really make sense, but let's just say it does. The particle's moving to the right when this graph is above the x-axis, okay? The particle or object is moving to the right or up, okay? Now, when this velocity function goes below the x-axis, that tells us that our particle or object is moving to the left or down. So it's in other words, it's moving in the opposite direction, all right? So what we're going to do first, we're going to find the displacement. For displacement, we don't care about total distance. We just care about where it's going to end up. And that really just means we're going to integrate this function. That's all we're worried about. We're just worried about where that particle ends up in comparison to where it started. Okay? Now remember, we're going from, it looks like 1 to 4. Okay? So I'm going to go ahead and sketch 1 on here. I didn't do a very good job of graphing this parabola, but that's all right. I'll erase it real quick. Okay, so just to show you this, so we are going from 1 to 4, okay? So that means the first part of our integration, this particle is moving to the left. It's moving in the left direction because this graph is below the x-axis. And then for the last, is it seconds? I don't even give us time, does it? Yeah, it does give us time. Seconds. For the last second, it moves to the right. Okay, I know that because the velocity is above the x-axis. Okay, so keep this in mind. This is actually what we're trying to figure out. What's the total? You know, where does it end up after this movement left and movement right? All right, so back to the. Let's go back to our assignment here. It's moving in the left direction because to figure out this net change in position, all you have to do is integrate 1 to 4 of t squared minus t minus 6. That's all you got to do, okay? Because when we're trying to figure out displacement, we want to know when it moved right and when it moved left, okay? We want that. We want to, be able to determine that. We want that to happen. We want to be able to calculate that. And so when we take all that time for where it moved to the left and we take all that time for where it moved to the right, it actually ends up negative 9/2 units to the left. So this particle moved 4.5 meters toward the left when it was all said and done. And by looking at our graph again, we saw that it was moving to the left at first, and then it moved back to the right and then settled at 4.5 meters to the left. So that basically is our displacement, 4.5 meters to the left of where it began. All right? And that's how you're always going to find displacement. That's all you have to do. Just integrate velocity, and don't worry about absolute value here. We're about to have to do that now, though. Okay, so when we're talking about total distance, okay, everybody look back over here at this camera again. When we're talking about total distance, now we don't want those negative values to show up. We've got this negative velocity, but we don't, we want that to be positive, okay? We want to somehow change that to positive. Basically what we want to do is, you can think of it this way. We want to flip this part of the graph over the x-axis. We want everything above it, because remember, we want to integrate a positive rate. We want to integrate a positive rate because now we're trying to find total distance. If any negative values come into play, then that's going to subtract and that's going to throw it off. We want total distance, okay? So anytime we're doing total distance, we need everything above the x-axis. What's that mean? We have got to integrate the absolute value of velocity. So in this case, it's the absolute value of t squared minus t minus 6. Now y'all need to pay attention to this because this requires more steps. Remember, displacement, all you got to do is integrate. That's it. Integrate the function, you're done. Real simple. That's why we want that problem, because it's real simple, real quick. We don't have to do much. We just need to know what to do. Now, if they ask us to find total distance, look underneath the camera. I hope everybody's looking underneath the camera. This is what you're going to write first thing, right here. This is going to show your grader that you know, that he knows, she knows, you are going to integrate the absolute value of your velocity. Okay, now, we obviously know where this crosses the x-axis, but let's say we didn't, and let's pretend we don't. And let's pretend you might not even be able to use a calculator at some of these problems. So what you got to be able to do is figure out where indeed this function is below the x-axis, okay? So how are we going to do that? Well, we've done all this stuff before. We've just done it for different reasons. We're going to set this equal to 0. We're going to set t squared minus t minus 6 equal to 0. We're going to figure out where it crosses the x-axis. So this is our first step. Well, we've written our integral, we've made a decision, we're about to integrate absolute value. But now what we're going to do is we're going to figure out, where is this function negative? So we want to factor it. No big deal. It's a pretty easy one to factor. It's a t. Let's see, t. We got negative. Is it minus t or is it minus 6? Oh yeah, that's right. T minus 3, t plus 2. So where does it cross the x-axis? It crosses the x-axis or t-axis at t equal 3, and t equal what? Negative 2. So these are the 2 points that are real critical in our analysis. See, something's happening, something's happening at these 2 points. The graph's either going above or below the x-axis, okay? Now, you already know what an upward-facing parabola, this is an upward-facing parabola. So you know that once it hit the graph at negative 2, it's gonna, it's coming down, and it hits and crosses negative 2, goes below the x-axis, and then comes back above the x-axis at x equals 3. All right, so you know that everywhere in between negative 2 and 3, and we've already graphed it as well, so you can see it, that it's below the x-axis. Okay? So in particular, on our interval, which is from 1 to 4, we have got to change this 1 to 3 interval. We've got to change this integral. We've got to do something with our function. We've got to make sure our function is positive, or at least the integral of our function is positive from 1 to 3, because we are trying to find the total distance. So everybody, look how we do this. So what we do, we have decided that our graph is below the x-axis from 1 to 3. So what we want to do is we want to write an integral. The first integral is going to be from 1 to 3. And what we're going to do is we're going to put a negative sign out front. We're going to put a negative sign out front. The reason we're going to do that is because we know what's going to happen. It's going to produce a negative value. This integral is going to produce a negative value because the graph is below the x-axis. So we need to force it to be positive. We need to force it to be positive. And so we're going to say negative integral from 1 to 3, t squared minus t minus 6. And then from 3 to 4, it's okay. It's already above the x-axis. We're not worried about that part because it's already above the x-axis. And so from 3 to 4, we're not worried about making it negative. It's positive. So just treat it as is. And that's it. Now, I forgot my DTs, but I hope you'll forgive me for that. I didn't have enough room for them anyway. But you need to put them, right? We need to put them. Get it wrong. So here it is. This is what we need to do right here to find total distance, everybody. That's it. You basically got 2 integrals. You got 2 integrals that you need to find. You need to integrate and add them together. All right. Let's look back at your presentation here. That's exactly what they did. Okay, it's exactly what they did. Look at that. They did it all by hand. Look at that. Look at that. Is that impressive or what? So here it is. This is what we so look, the total distance traveled was 10.1667 meters. That means going left and going right, everything it traveled, all that distance that it traveled added up to 10.1667. Remember, the 4.5 meters to the left is a displacement, okay? It's calculating positive and negative movement, whereas this is the total distance only calculates positive numbers. Positive. And how did we do that? We threw a negative in front of that first integral. Okay? So that's the idea. So when we're trying to find displacement, you integrate the function. Period. End of story. Easy, easy, easy. But if you're finding total distance, you have got to determine where that function is below the x-axis. Now, is it always below the x-axis? No. sometimes it's beautiful. You don't have to worry about it. The entire rate function is above the x-axis. If the entire rate function is above the x-axis, well, you don't have to worry about absolute value. Now, do I still want the grader of my paper to see it? Sure. I still want them to see that I realize that it's absolute value. But I'm not going to worry about analyzing it too much because I know the rate's above. But a lot of times you can't tell that. You're going to have to. It may be a calculator-based problem, or if it's not a calculator-based problem, it'll probably be a quadratic, something like we just saw here. Okay, something that's pretty easy, something we're really familiar with. All right. Let's look at number 1. Let's do one of these together. We got like 4 problems. And I want us to practice the process of displacement, finding displacement, and so here are your directions. In problems 1 through 4, a particle moves in a straight line with a given velocity. Find the displacement and the total distance over the time interval. All right. Now, they're not going to grade your graph. Unless they tell you to graph it, they're not going to grade your graph. They're just going to be looking for your integral. Obviously, if your answer is correct. So that's why it's so important in these stages when we're learning this material that we know what these graphs look like. And so what we might want to do while we're doing these problems today, at least, is go ahead and sketch a graph. Go ahead and take a look at, this is 12 minus 4t. But again, you don't really have time to do this on the AP test, right? You know what I mean? You just need to know, hey, look, this. I mean, a lot of times they're going to give this to you as a calculator-based problem. But, still, we want to kind of know what it looks like before we ever graph it, so we don't have to. All right, 12 minus 4t, we know that has a y-intercept up here at 12. We also know that it has a slope of -4, so it's down 4 over 1, down 4 over 1, down 4 over 1. So that's going to hit the x-axis at +3. Now, if you can't figure that out that fast, what do? Like I did a second ago, the first thing you do, well, actually, the first thing you do, the displacement, right? What are we doing? Displacement. So the first thing we need to do is write our integral. We're going to do the displacement of a particle from what? 0 to 5 of 12 minus 4t dt. Okay? All right, there it is. That's what we're doing. Displacement. Simple. Just all you do is integrate. That's all you do. Don't worry about absolute value. Just displacement, period. That's it. Now, again, we can graph this to kind of see what's going on. We're going from 0 to 5. Okay? So obviously, everybody in this class can figure out that the velocity starts out positive. Okay? So all of this integration is going to produce a positive value, a positive net change. Uh-oh, but at 3, what happens? It goes below. Now, I'm not really worried about that right now because I'm doing displacement, but here in a second when I do total distance, I'm going to be worried about that. All right? But this is pretty simple, so let's just go ahead and knock this out. So this is going to be 12t minus 2t squared. We're going from what? 0 to 5? Okay, first part's finding displacement. This is displacement. Should have written that at the very beginning. Displacement. Net change in position. Net change in position. How far have I moved from my original location, and in what direction have I moved? In fact, when you finally answer this, you will want to state both. Okay? All right, so this is 12 times 5 minus 2 times 5 squared. This is number 1, by the way. So everybody wants to be doing this because this is part of your homework. We're knocking it out in a hurry. And then this is just going to be 0. This is just going to be 0. If I plug 0 into that expression, it's just going to be 0. Right? So we got, what's 12 times 5? In fact, when you finally answer this, what's 12 times 5? 60. What's 25 times 2? 50. What's 60 minus 50? 10. Our displacement is positive 10. What does that mean? What does that mean? 10 units to the right. To the right. So you're going to want to put to the right or left. So if you got a negative number, you would say 10 units to the left. Okay, so you'd have negative 10, and then you would write 10 units to the left, so they understood me. You knew what that meant. So we're 10 units to the right, okay? 10, our displacement, or 10 meters, I guess. Did they give us meters? What does that mean? They gave meters per second. Meters per second. All right, we have a quantity because we integrated a rate. So we got 10 meters. 10 units to the 10 meters to the right. So you'd have negative 10, and then you would write 10 units to the left, so they understood. Now, that's displacement. So we're How about total distance? First of all, any questions on displacement? Okay. Or 10 meters, I guess. Did they give us meters? All right. Now, total distance, that's where we have to worry about where this function is positive and where it's negative. Now, we've already done that analysis, okay? So, you can graph, you can, if you don't want to draw a graph, you know, you could set it equal to 0 like we did, set it equal to 0. Actually, I don't think I ever did set this one equal to 0. It's 12 minus 4t equals 0, and this is t is equal to 3. And then if you don't know for sure where it's above the x-axis and where it's below the x-axis, you can just choose a number between 0 and 3, for example. Now it's obvious on this one, but if it was some harder function that you didn't know where it was above and below, just figure out where it crosses the x-axis, and then choose a number between 0 and 3. Choose a number between 3 and 5, and figure out, whether it's positive or negative in that region. And that's a good way to do it. All right. Choose a number, plug it into the velocity function, and it'll tell you whether it's positive or negative. All right, so this again is total distance. And from the looks of things, we see that the velocity function goes below the x-axis at 3. All right, so first of all, we're going to show our knowledge of the situation. We're going to say total distance is from 0 to 5, and we're going to say the absolute value of 12 minus 4t dt. All right, that tells them, hey, look, we know what we need to do. We need to take the absolute value of our function. We see that the velocity function goes. Now, this equals. Okay, so here's our two integrals. From 0 to 3, the function is above the x-axis, so we're not worried about that part of it. It's going to come out positive anyway. It's going to be positive anyway, because when we integrate a positive rate, we get a positive change. So this is 12 minus 4t. Now this equals dt. So here's our two integrals. Okay. From 0. But on the next integral, instead of putting a plus sign out front, I'm going to put a negative sign out front. Why? Because I know when I integrate from 3 to 5, this integral is going to give me a negative value. And I don't want that to happen. I want it to be a positive value. So I'm going to force it to be positive by putting a minus sign out front. And then we'll have a minus, a negative, and you'll have plus. And that's all there is to it. Now from here, it ain't fun, right? Because you got a lot of work to do now, right? By doing this by hand. I've done this previously, so in case I make any mistakes, I can fall back on the answer, solution. Okay, so this is what we've done. We've set up our integral, absolute value. We've broken that integral up into two separate integrals. One was okay, it was 0 to 3, this was positive anyway. From 3 to 5, this is going to be a negative accumulation, or a negative net change. So we want this to be positive, so we throw a negative out in front of that. And from there, we just want to integrate. So we're going to have 12t. Again, the same thing as we had before, t squared. We're going from 0 to 3. We've broken that integral up into two separate integrals. One was okay, it was 0 to 3, this was positive anyway. T from 3 to 5, this is going to be a negative accumulation, 2t squared. So we want this to be positive, so we throw a negative 3 in front of that. To 5. And from there, we just want to integrate. So then it gets really long. So now you got f of b minus f of a over here, and you're going to subtract f of b minus f of a over here. So you can see this can be a headache, because you got to really pay attention to what's going on here. This subtraction and all that. Okay, so it's 12 times 3 minus 2 times 3 squared. So now you got f of b minus f of a over here. So that's f of b on our first integral. Thank goodness, 0. See, I told you how happy you would be when you'd see 0. Look, is that the happiest time you've ever seen 0 in your life? There ain't never been a better time than 0 right there, right? Boom. No, don't even have to calculate anything. It's beautiful. All right, what about this one? This is 12 times 5 minus 2, 5 squared on our first integral minus 0. F of a, that's 12 times 3. It's pretty nice outside today, guys. Went out there a second. It was beautiful out there. Beautiful. Beautiful. All right. I ran out of room down there at the end. Okay, so this is 12 times 3, 36. 3 squared is 9 times 2 is 18. So this is 36 minus 18, which is 18. And then 18 minus 0 is just 18. So look what comes out of that first bracket there. That entire f of b minus f of a is simply 18. Thank goodness for that 0 right there. That really helped out some things there. All right. I gotta be a little bit more careful with this bracket over here. 12 times 5, 60, 5 squared. We already did that up here, so we know that's going to be 12 times 5, 60. That's 10, right? 10, and then, okay, whatever this is, that's 36. We did that here. So that's 18. That's 18. So we already did the 12 times 3 minus 2, 3 squared. We got 18. So now we know it's also 18 over here. So that is good. And sometimes you'll repeat. You're repeating the work that you've already done, so you'll know what the answer is. 18 minus. Okay, this is what's 10 minus 18. It's 10 minus 18. Negative 8. What's 18 minus a negative 8? So that's 18. So we already did the boom, 26 meters. That's its total traveled distance. That's its total. That's the total distance it traveled right there. When it went left, it was going right at first, then it started coming back left. Well, that total distance that it traveled along that path, going right, going left, ended up being 26 meters. Okay. It ended up 10 meters to the right of where it started, and that's its displacement. Its total distance is 26. All right, let me know questions about this. The total distance it traveled right there. When it went left, it was going right at first, then it started coming back. All right. Well, let's look at number 2. Can you do one on your own? Let's see if you guys can get started on the second problem and knock it out. It ended up before we acknowledge it. We got 36 minus 24t plus 3t squared from 0 to 10. All right, there's a quadratic for you. All right, let me know questions. Get after it. I know you can do it. Let's see what we all come up with. Oh, I don't have this answer. Oh no, I'm gonna have to work through it. All right. Well, let's look at. Remember, you can always verify your work now on Desmos by typing in the integral. Get started on the second problem and knock it out. But we want to go ahead and try to do this by hand. We get 36 minus 24t plus 3t squared from 0 to 10. Great pencil sharpener over here, guys. Y'all don't know what you're missing out on over here. Get after it. I know it's the best pencil sharpener in America. Oh, I don't have this answer. Oh, maybe. No, I'm gonna have to work through it. Top 10%. Remember, you can always verify your work now on Desmos by talking to them. Testing. Are y'all still there? Is everybody at home? Hello? There we go. There we go. It's the best pencil sharpener in America. Very nice. Thank you. Okay, number 2, guys. Let's go total displacement. Total displacement first. Or you don't say total displacement, just say displacement. Displacement. There we go. Okay, I'll give you a second to find displacement. 2a. Okay, number 2, guys. Let's go total displacement. Okay, I'll give you a second to find displacement. 2a. All right, if y'all got an answer, go ahead and throw it into the chat. Let's see what y'all came up with. Ding, 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 Katie. All right. At least that's what I got. All right, if y'all got an answer. I got 160 as well. Let's see what y'all came up with. Hytrons. Woo. All right, there it is right there. So remember when you're trying to just find the displacement, all you have to do is integrate the equation. So the zero again comes in handy.